So I'm going to jump into my lecture for section 4.3. The whole chapter, for chapter 4, I might generically call this chapter's roots / radicals. I'm going to use those words interchangeably as we go through the chapter. Let me just start out with a generic square root symbol. There's kind of the word root, because I just generically would call that a square root symbol. And sometimes I call that a radical sign, so hence the names root and radical. When I'm dealing with a square root symbol, usually I'm going to have some expression written under the square root. For instance, I might say the square root of 16. In this particular expression, the square root of 16, the 16 is called the radicand. Usually when we're dealing with radicals or roots, which I'll use the words interchangeably, usually there is a number that's written in this little cup area. And for a square root, there's no number written, but it's an implied 2 that's going to be assumed in that little cup area. And that 2 is called the index. I don't do a lot of terminology, but in this chapter, to know the word radicand and the word index that's a big deal. So these are words that will come up a lot. And I hope most of you know that the square root of 16 is 4. The square root symbol by itself it asks the question, what positive number squared equals the radicand? Square roots, by that symbol, the square root symbol, want positive results as opposed to negative. And the answer to this, what is the square root of 16? The square root of 16 is asking what positive number squared equals 16, and that's going to be 4, because since 4 is the positive number that when you square it, you get 16. I'm probably lazy sometimes with terminology. Technically, this symbol that I wrote here, this is actually called the principal square root symbol as opposed to just the generic square root symbol. I never really use the word principal. Principal here really meaning positive. In our class, we'll do lots of radicals. This is going to be a cube root symbol, or cubed root symbol. And in this particular problem, the index is 3. And the cube root symbol asks what number cubed equals the radicand, and it doesn't specify positive. Square root symbols require positive answers, but cube roots, sometimes I use the word cubed. Cube roots just says what number cubed, and it doesn't specifically have to be positive. Cube root asks what number cubed equals the radicand. The reason in square roots we make a big deal that this needs to be a positive answer is because a number there are two numbers that generally can be squared to equal the radicand. The positive and negative versions of the numbers, both, if you square them, equal the radicand. And because there's two different numbers that when you square them equal the radicand, we pick the positive. In the world of a cube root, this isn't an issue because when you cube a negative number, it's negative. Let me just do a generic cube root of a negative number. Like if I asked, what is the cube root of negative 8? This is asking the question, what number, either positive or negative, cubed equals the radicand? And I know the answer is negative 2, since negative 2 cubed is negative 8. It's going to be important to be able to do basic radicals on your calculator, and depending on the calculator that you own, it might work slightly differently. Very specifically, on the calculator that I use for class, square roots are super easy to find. There's a square root symbol on my calculator. Most calculators have a square root symbol. Super easy to activate it. If I wanted to do the square root of 16 on my calculator, I'd type the square root button, type the number 16, and then I'd hit equals, and I get the positive 4. If I want to do cube root, usually calculators don't have a main key for cube root. You're going to have to hunt around on your calculator, and on my calculator, the cube root key is written above the square root key, and I'm not sure that you could even read this with the font that it's showing. But on my calculator, the cube root key is written in this brownish color. And if I want to do the cube root of negative 8 on my calculator, I'd hit the shift key, which is the brownish colored key, the square root, and that will give me the cube root. For a negative on my calculator, I need a negative in a parentheses as opposed to the minus sign. And that's going to be a big deal as we're going through this section. If you're using your calculator to do some computations, if you use a minus as opposed to a negative, or a negative as opposed to a minus, you might get an error. So if you get an error as you're going through and doing some calculator work, you might have just used the wrong negative. But for my purposes here, I'll do negative and then 8 to do the cube root of negative 8, and that'll give me negative 2. We're going to do 4th roots, 5th roots, 6th roots, and all the roots more or less work the same. If I wrote this symbol, I would say this is a 4th root. And symbol. The index is 4 for this. And when the index is even, it requires a positive answer, as opposed to if an index is odd, it can accept negative answers. A 4th root symbol asks what positive number raised to the 4th power equals whatever the radicand is. And the radicand is the number or the expression under the radical. So when the index is even, 4 is an even number, it's hence an even index. 2 is an even number, hence an even index. When the index is even, the answer is supposed to be positive. When the index is odd, it can be either positive or negative, depending on what the radicand is. If the radicand is negative and the index is odd, you get a negative answer. If the radicand is positive and you're doing an odd index like a cube root, like the cube root of 64, the cube root of 64 is just 4. Or having issues with fitting things onto the screen right now. Hopefully I'm not going off the screen more often than I'm on the screen. So for a cube root or any odd index, the cube root of a positive number is a positive number, the cube root of a negative number is a negative number. And an even index, the square root of a positive number is a positive number. The fourth root of a positive number is going to be a positive number. And we're not going to talk about fourth roots and square roots of negative numbers until later in the chapter. Actually, we'll talk about square roots of negatives, not even fourth roots of negatives. We'll hold off on those for now. So if I wrote a problem like this, what is the fourth root of 81? This is asking me what positive number raised to the fourth power is 81. My calculator doesn't have a special key for fourth roots. Most calculators won't. On my calculator, I don't know that you can see this so well, but it has a key that looks like this. It has a radical symbol and an index boxed, and this will allow me for my calculator to enter any index that's not a square root or a cube root. If I wanted to do the fourth root of 81 on my calculator, I'd hit Shift and the X with a square, and that would give me the template for a fourth root. And then I'll do 4 for fourth root, use this kind of mouse key, and then 81, and the fourth root of 81 is 3. For a even index, the answer is always going to be positive. So that should be enough for us to kind of jump into the section. This is going to be a calculator heavy section unless you just know the radicals in your head. So you should get the calculator that you're going to use. And I'm going to try to get done with problems 1 through 29 odds on this portion of the video. And then we'll go to a second portion and then a third portion of the video. So this is the start of the lecture on section 4.3, and I should do all the problems between 2 and 30 that are even. For homework, you should do 1 to 29 odds. So for homework, for this portion of the video, you're going to want to do 1 to 29 odds. And if all you do is press buttons on your calculator because you don't have these facts memorized, completely fine. I'll do them all on my calculator as well as try to talk through them. When I look at problem 2 asks for the square root of 16. It's asking me what positive number squared is 16. And because 4 squared is 16, the square root of 16 is just going to be 4. On my calculator, it's just square root button followed by 16, and it tells me that it's 4. For problem 4, a negative in front of a radical is an implied negative 1 times whatever the radical is. And the radical, it gets treated like an exponent in terms of orders of operations. So like the PEMDAS, the parentheses, exponents, multiplication, division, addition, subtraction. Radicals go right here. Radicals, we'll find out a little bit later, are really fraction exponents in hiding. So in terms of orders of operations, the radicals get treated like exponents. So if I was trying to find the negative square root of 36 without my calculator, I know the negative in front means negative 1 times the square root of 36. I know the square root of 36 is asking me what positive number squared is 36, and I know that that's going to be 6, because 6 squared is 36. And then I'll do the multiplication, because I do exponents first, and radicals are considered fraction exponents, and then negative 1 times 6 is negative 6. On my calculator to do this, I use the negative, not the minus, by the equal sign, and then square root button, and then 36, and that gives me the negative 6 that I need. Problem 6, this is the 7 is not the 7th root. This means 7 times the square root of 25. Orders of operations, I do radicals like exponents, so radicals going to get done before the multiplication. Square root of 25 says what positive number squared is 25, and that's going to be 5. And then 7 times 5 is 35. On my calculator, I can just go 7, type the square root button, type the number 25, and then hit equals, and I'll get the 35 that it should be. 8 just asked me what number cubed is 27. I know that 3 cubed is 27. I don't need a calculator to write this down, but I can do this. On my calculator, I do shift and square root, type the number 27, and the cube root of 27 is just 3. 10 wants the cube root of negative 125. This is asking me what number cubed equals negative 125. And I know that to be negative 5. I know that negative 5 cubed is equal to negative 125 because negative 5 cubed is negative 5 times negative 5 times negative 5. When you multiply 3 negatives, you get a negative. When you multiply 3 5s, you get a 125. But on my calculator, if I didn't know that, shift and square root for the cube root, negative 125, and it gives me the negative 5. Again, if you get an error when you're dealing with the minuses, you're probably using the minus as opposed to the negative, or the negative instead of the minus. Problem 12 means negative 1. That negative means multiply whatever the cube root simplifies to by negative 1. It's negative 1 times the cube root of negative 27. I do the radical first. The cube root of negative 27 says what number cubed is negative 27, and because negative 3 cubed is negative 27, the cube root of negative 27 is negative 3, and then I do the multiplication. Negative 1 times negative 3 is positive 3. On my calculator, pretty easy to do. I do the negative sign, shift and square root for the cube root, the negative sign, and then 27, and my calculator will give me 3. 14 says what number cubed is equal to 1, and 1 to any power is equal to 1. So because 1 cubed is equal to 1, the answer to 14 is going to be 1. To do this, I do shift and square root to get the cube root symbol, type the number 1, and I'll see that the cube root of 1 is 1. To do the square root of a fraction, I need to separate the numerator and the denominator in my head. I need to separately do the square root of the numerator and the square root of the denominator. I can do this without a calculator if I know both of these square roots. The square root of 49 is what positive number squared is 49, and that's 7. The square root of 25 is what positive number squared is 25, which is 5. The answer to 16 is 7/5. I don't need a calculator for it. My calculator does fractions so well. On my calculator, I type the square root button first, then the fraction key, type the number 49, use a little replay button here to get the fraction entered up. I type the fraction under the square root, and that tells me that it's 7/5. Most calculators don't do fractions as nice as this. If you're having calculator issues, shoot me an email, tell me the calculator you have, take a picture of it, and maybe I can give you an idea of how to work your calculator. 18, it's the cube root of a fraction that has to be computed by doing the cube root of the numerator separately from the cube root of the denominator. The numerator is the cube root of 8. Ask me what number cubed is 8, and 2 cubed is 8, so the cube root of 8 is 2. The denominator wants the cube root of 27. The cube root of 27 is what number cubed is 27, which is 3. If I was doing 18 by my calculator, I do shift and square root for the cube root, fraction key, 8 in the numerator, 27 in the denominator, and it's going to give me the 2/3. Because I could do most of these in my head, you don't have to do these on your you can do them on your calculator. There's no work that needs to be shown. 20, ask what positive number raised to the 4th power is 81. And I know that 3 to the 4th power is 81. I know that the answer for this is 3. If I didn't know this, to activate the 4th root on my calculator, I'm going to use the shift key and then the x to the square, the x with a square, and that gives me the template where I could type a 4 in for the index and move over and type an 81 in for the radicand to give me the 3 that I need. 22, this is 2 times the 4th root of 81. This is frustrating to enter on my calculator. By hand, I do the radical before the multiplication. The fourth root of 81 is 3, so this is just really 2 times 3. The answer should be 6. On my calculator, if I try to type the problem and make it look like this, it's going to bug me. If I try to do this, go 2 and then shift square root, all of a sudden it doesn't make the 2 a times the radical. On my calculator, to do this, I have to go 2, hit the times key to separate the 2 from the radical, and then shift X with an X, the X box power key, and then I'll enter it like that. So I physically have to put a time sign. If I don't physically put a time sign, it's going to take the 2 and make it as the index. 24, that negative in front of the radical means -1 times the result of the radical. I think I could enter it just like this, but I'll find out in a second. By hand, the fourth root of 81 is 3, so this is really -1 times 3, which is -3. On my calculator here, it's negative by the fraction, and then shift in template for this fourth root. My calculator let this go because it never is going to make the index negative. But I could have entered it as -1 times shift fourth root of 81 and still got the same -3. 26 is what number raised to the 5th power is -243. And on my calculator, it's just shift X with an exponent thing to give me the template for the 5th root, and then -243. That one, if you don't have it memorized, I would just use your calculator. 28 is 3 times the square root of 49. I do the square root piece first if I'm working without a calculator, and hopefully you have the square root of 49, at your fingertips memorized. So this would really be 3 times the square root of 49, which is 3 times 7. And 3 times 7 would be 21. On my calculator, this is just straightforward. I type the number 3, I hit the square root button, I type the number 49, and then I hit equals. And then for 30, this is 5 times the cube root of 64. The cube root of 64 is what number to the 3rd power is 64. And because 4 to the 3rd power is 64, this is just 5 times 4, which is 20. On my calculator, just type the number 5, then the shift and the square root key to get my cube root, then the number 64, and that gives me the 20. That's probably a good place to stop this portion of the video. So I'm going to go ahead and just stop this right now, and we'll go to a part 2 in a second here.